Okay, this is Math 1325. I'm going to be working through the Day 1 Basic Skills Review. And we're going to go ahead and get started here. There's 10 problems. So the first problem is we are trying to take this expression, which is the fifth root of x raised to the ninth power, and we're trying to convert this from what's called radical notation over to what's called, exponential notation. So we're just trying to change the look of this. We're not actually doing any sort of mathematical process. And what we're going to be using is this property right here, that if you have a root and we have the nth root of something, let's say x raised to the m power, that this is equivalent to raising x to the m divided by n. So this is called radical notation, and these are called rational exponents. Rational meaning ratio. This is an exponent that's a ratio. This fractional exponent is equivalent to this expression, which is a root. So these two things mean exactly the same thing. So what we're going to do is we're just going to rewrite this as x to the 9/5. So whatever the power is in here becomes the numerator, and whatever the root is on the outside becomes the denominator, and that's it, we're done. So in a business calculus class, we're going to want to work with all of our variable expressions, and we're going to want them to be in this notation as opposed to this notation. So we need to be comfortable going from here to here. All right, in the second problem, we have 1 over the fourth root of just x. And remember that means that x is raised to the first power here. So first thing I'm going to do is just use this property again. I have the 4 as my denominator, the 1 will be my numerator, and I'm going to leave this as 1 over, and then I'm going to rewrite the bottom as x to the 1/4. And normally that would be okay. But again, in a business calculus class, we actually don't want this in the denominator. We're going to actually want to move that up. So remembering a property that if you have x to the negative n, that we were told that if you have a negative power, you drop it down. You could rewrite this as 1 over x to the positive n. On the other hand, if you have 1 over x to a negative n, so if you have 1 divided by x to a negative power, you can bring this negative power up, and it becomes positive, so x to the positive n. And it just joins the one that was already up there. So looking at this right here, we can kind of use this property, except that it's not negative. So if this property says that a negative power comes up and becomes positive, then that means a positive power should be able to come up and become negative. So you could look at it that way, or you could also say, hey, it's this property right here. We're actually going from here to here, like this. 1 over x to a positive power, converting it to this. And this is what we want to work with in a business calculus class. It's okay to have a negative exponent in a business calc class. So that's the first two problems. These are your two answers, right here and here. And now let's move on to number 3. So for number 3, you're asked to multiply and simplify. So just practicing some of our basic algebra here. In this particular case, we are practicing expanding two binomials. So this is a binomial, it has two terms. This binomial has two terms. We're going to expand them or multiply them together. And this is also, in this case, you could call this FOIL if you want, but the technique is to multiply this times this, then this times this, then this times this, then this times this. Put it all together, collect all your like terms, and simplify. So let me do that first multiplication. 5x times 4x, that should give me 20x squared. And then 5x times negative 7 is negative 35x. And then negative 2 times 4x is negative 8x. And then negative 2 times negative 7 is going to give me a positive 14. All right, so this is equivalent to this. And now collecting like terms, these two terms can go together because they're like terms. They have the same variable raised to the same power, so they both have x's to the first power. Put those together, we're going to have 20x squared minus 43x plus 14. So we're doing negative 35 and we're taking away 8. That gives us negative 43. And at that point we're done. So that's it for number 3. Now number 4 is going to look weird. I'm sure you've done something like number 3 before. Number 4 is going to look weird because on number 4 you're asked to simplify again. But you know what you're starting with here looks very like kind of like, when have you ever started a problem like this? And I know it looks strange. But as you're going to see in this class, we're going to be doing something later, and when we do this particular process, it's called differentiation. When we do it, we're actually going to get this as kind of like our first step. So we're going to start with something, and then we're going to do something called taking the derivative, and when we do that, we're going to get to this, and at this point, we need to be able to just clean it up. And so that's what we're being asked to do here. So don't worry about where this comes from right now. Let's just work on the mechanical parts of cleaning it up. So we're going to multiply, we're going to distribute over here, right? Expand this out. We're going to multiply those together, figure out what that is. Then over here, we just have a 3 times this, so we're going to distribute the 3 through, figure out what that is, but keep in mind we have a minus here. Then on the bottom, what I want us to do is not even worry about squaring that. We're just going to leave it alone. So let's go ahead and multiply. 4x times 3x gives us 12x squared. 4x times 8 gives us positive 32x. And then negative 1 times 3x is minus 3x. Then minus 1 times 8 gives us minus 8. So that takes care of this top left piece. Now we have minus, and I don't want to mess up that negative sign because that negative sign is going to need to go through and pass through everything over here. So let's figure out what this is first, right here. Let's figure that out. So I'm actually going to put this red bracket to kind of separate it. When we distribute the 3 through here, we get 6x squared, and then we get minus 3x. And that's what would be left if we distributed the 3 through. We still have to pass the negative through. Okay, and on the bottom, we could square that. But again, because of where we're headed in this class, most of the time, we are actually not going to do the actual squaring here, on the denominator only. So trust me that later on this will make a little more sense. So let's just leave the denominator alone, and let's continue here on top. I have 12x squared. These are like terms. I can put those together. So if I take 32 and take away 3, that should give me 29 x's. So plus 29x. And then I have minus 8. And then here, this negative is going to distribute through. It's going to change this positive 6x squared to minus 6x squared and change the negative 3x to a positive 3x. So minus 6x squared and plus 3x. Then all of this is still divided by our denominator, 3x plus 8, that quantity squared. And now again, I go through and I see if I can't collect any like terms together. And I notice that I have 12x squared, I can take away 6x squared. And then I have 29 x's, and I can add 3 more x's to that. So I can collect those like terms. Let me just put that result up here. So 12x squared, take away 6x squared is 6x squared. And then 29x plus 3x is going to be 32x. And then finally minus 8 over 3x plus 8, that quantity squared. Okay, that's it. That's all we're going to do at this point. Leave it like that. We're good to go. Okay, so again, this problem is just about making sure you know how to, distribute this through or expand this out, and then pay attention very closely to that negative sign. Okay, that's a big mistake students make, is they forget about this negative sign, and then cleaning it up at the end. All right, so that's number 3. Let's look. That was number 4, yeah, that was number 4. Let's go ahead and move on to number 5. All right, factoring. Okay, you must be able to factor in this class. So here's some things to look at. So this right here is a quadratic. It's a trinomial, 3 terms. So the first step to factoring anything at all is to look for a greatest common factor. So is there a number that all these 3 numbers have in common? There's not. Is there a variable in common to all of the terms? And the answer is no. So we do not have a greatest common factor to pull out. So at this point, it all depends on you and your background, how comfortable you are factoring trinomials. Some students are just going to do kind of a trial and error method, which is usually the most efficient, the fastest way, but it takes a lot of time to get good at this. I'm hoping that you're kind of here. If you're not, I'm going to show you a different way to do this. But I'm going to kind of say, all right, I need 2x squared, so I'm going to try 2x and x. That'll give me 2x squared. And then I need these last 2 numbers to multiply to be negative 12. So I can do that different ways. Like I could try like 2 and 6, and let's just see what would happen. If I did that, I would get 2x squared, and then here I would get 12x, right? And then here I would get 2x. Now I need this to be a minus 12, so I need one of these to be negative. But I don't think it's going to work. Like if I make that negative and that positive, you can see that I'll get my 2x squared, I'll get negative 12x, but then plus 2x, that's not negative 5x. So that doesn't work. And if I change the signs, make this one minus, this one plus, I still get 12x and minus 2x, that's 10x. I can't, it's not working out that way. So maybe 2 and 6 are no good. What else multiplies to be 12? How about 3 and 4? So I could try like 4 here and 3 here. And let's see, if I do that, 2 times 4 is 8, and then 3x. So 8 and 3, I should be able to get a 5 out of 8 and 3. So why don't I make this minus? That way it'll give me a negative 8x. And then make this a plus, which will give me a positive 3x. That should come together to be this. So that looks like it'll work. Let's try it. 2x times x is 2x squared. 2x times negative 4, I'm going to write this down. 2x squared, 2x times negative 4 is negative 8x. And then positive 3x in the middle. And then minus 12 on the end. And then these two together become this. So that works. That's the trial and error method, all right? And again, the more of those you do, the faster you get. Now the other method is what was referred to as the AC method. And to do that, you're kind of going to do the same thing. You're going to take this number here 2 and multiply it times this number right here. You have to multiply those 2 together. That gives you negative 24. And then you take the number here and you write it negative 5. Okay, and then you still have to come up with the list of numbers that multiply to be this and add to be this. So we have to start thinking, what are the different ways I can get negative 24? So I can multiply negative 1, I'm going to do comma 24. I can multiply those 2 together, I would get this. But if I add those 2 together, I'm not going to get that. So this is out. How about 2 and 12? 2 and 12, I need to make one of these negative, so let's go with negative here. So if I multiply those 2 together, I get this. If I add these, I get 10, which is not that. Even if I change the negative over here, I get negative 10. It still won't work. So how about 3? 3 and 8. Hey, this may work. Okay, look, if I make 3 times negative 8, that gives me negative 24. And if I add these 2 numbers together, I do get negative 5. So these 2 numbers are going to work. So what I'm going to do is I'm going to just write those numbers down here, 3 and negative 8. And then at this point, this is where things, again, it just depends on what you've learned in the past. The way it's taught normally here is that you're going to rewrite this expression. You're going to write the 2x squared. You're not going to change that. You're not going to change the minus 12 at the end. But what you are going to do is you're going to rewrite this negative 5x. You're going to rewrite that using these 2 numbers, 3 and negative 8. So what you're going to do is you're going to put plus 3x and minus 8x. Notice that I had to attach the x to it. This was just so we could get what numbers work, but we need the x's so that it matches up with this. So once you're here, this is equivalent to that expression, but now you have 1, 2, 3, 4 terms, and when we factor 4 terms, we can do grouping. So what we do is we split this down the middle. Right after the second term, you split it, and then you factor out of this, just these two, ignore this, factor out a GCF. So they both have an x in common. I'm going to pull an x out. I'm left with 2x plus 3. And then what we need over here is to pull something out that's going to leave us with a 2x plus 3. So notice that both of these numbers, if you pull out a negative 4, hold on a second. Okay, sorry about that. I'm probably going to get a couple of other calls here. They're doing fire drills in the building. Okay, so you pulled out an x here, you pull out a negative 4 here, and notice that these two match. And that's what we're looking for. Once those two match, what we can do is we can factor that out as a 2x plus 3. And then what's left is this and this. So if I pulled this out of this term, I'm going to have an x there. If I pull this out of this term, I'm going to have a minus 4 left there. And so I put those in parentheses, and this is the result. So you can see that this here matches what we got here. A little bit longer, a little more involved, but it's still a procedure. So I hope that you're at a comfort level with factoring trinomials where you can get those relatively fast. Going to be doing quite a bit of factoring in this class. All right, so now let's move on to number 6. So for number 6, we have 16x squared minus 25. And we're asked again to factor. And when we're factoring this, again, we look for a GCF. Is there a greatest common factor? Is there something that these both have in common? Nope. So then we go on to our methods. And now we recognize that this is 2 terms. And when you have 2 terms, you can't use the method we just used. This is hopefully, well, when you have 2 terms, you have to hope that it's a special type of expression. And in this case, I hope that you can see this looks like a difference of squares. You have subtraction, 25 is a perfect square, 16 is a perfect square, and x squared, of course, is a perfect square because x times x is x squared. So if we can somehow use this formula, a squared minus b squared, this is the difference of squares formula, equals a plus b times a minus b. If we use that formula, we should be able to factor that. The question is, what is a for us over here and what is b for us over here? So very carefully pay attention to the fact that 16x squared can be rewritten as 4x in parentheses squared, and then minus 25, which is really 5 squared. So notice that by putting the 4x in parentheses and saying squared, I would have to square both the 4 and the x, and that would get me back here. This is not the same thing. 4x squared is not the same as 4x in parentheses squared. This just squares the x. So this is not, right? That is not that. This is actually this. So now what you can see is that this whole thing right here is like the a, and this whole thing right here is the b. So what I can do is just go to this formula. I have a squared minus b squared should be equal to, see, a, which is 4x, plus b, which is 5, and then a, which is 4x, and then minus b, which is minus 5. So there you go. That's it. It's factored. It's been broken up into a product here. And then we could FOIL this back out, and if you did, you would get back to this. So that would just verify that you got the right answer. So you need to be able to recognize differences of squares in expressions. All right, moving on to number 7. Moving on to number 7, we have 16x squared minus 81 equals 0. And we're asked to solve the quadratic equation by factoring. So they do want us to factor this right here. Oh, here it comes. Told you there would be another call. That ringer is loud. Did I unmute? Yeah, okay. Okay, now, they want us to factor. So what I'm going to do is I'm going to factor the left-hand side. Notice again, this is two terms. Looks like a difference of squares. I notice that that looks like a 4x that's being squared. Again, identical. This time though, it's a 9 squared instead of 5 squared, like the previous problem. But see, now we have an equation, so we have to go a little further. This breaks down using the difference of squares formula to 4x plus 9, 4x minus 9 equals 0. And once you have factored something, and if it's being set equal to 0, and it has to be 0, and there's multiplication here, then what you can do is you can take each one of these and set each one of those equal to 0. That's what I'm going to do now. That's called the zero factor property. So I'm going to take 4x plus 9, set it equal to 0. I'm going to take 4x minus 9, set it equal to 0. And I'm going to solve each of these equations. These are now little linear equations. So to solve these, you've done these plenty of times, minus 9 on both sides. 4x equals negative 9, and then divide by 4x is negative 9/4. Okay, over here, 4x, move the 9 to the other side by adding 9 to both sides. And you get 4x is 9, so x is positive 9/4. So you have two solutions in this problem. It is negative 9/4 and positive 9/4. All right, moving along. Problem number 8. Solve the following quadratic equation by the quadratic formula. So we have minus 12 equals 0. Okay, I might need my calculator for this. I haven't actually worked these problems out, so in anticipation of needing my calculator, I will get it. Okay. All right, so we need to use the quadratic formula. That's what they're telling us to do it that way. So you need to remember the quadratic formula says this. I'm just going to put QF for quadratic formula. It says that if you have an equation that is quadratic and looks like this, so if this is your equation, then the solutions to that equation are x equals negative b plus or minus the square root of b squared minus 4 times a times c, the entire quantity divided by 2 times a. So that's something we need to know. And all we have to do is just take our numbers, plug them in, and then evaluate this expression. So we have x is equal to, negative b means the opposite of b. So for us, b is positive 16. So we're going to take the opposite of that. It's going to be negative 16. Had this been negative 16, that would be positive 16. All right, plus or minus now. So this is where you are probably going to need a calculator at some point, especially for these parts in here. So you're going to take, okay, where are we? B squared, right, is the next thing. So we're going to take the positive 16, we're going to square it. And that's 256. Now, if this had been negative 16, just so we can cover this, it still would be positive 256 because when you square a negative, it becomes positive. So when I square that, we get 256 here minus 4 times a, which is 3, times c, which is negative 12. So be careful with that. All over 2 times a, but a is 3. All right, so now, at this point, I don't need this formula anymore. This will be equal to negative 16 plus or minus. The plus or minus is telling us that we potentially are going to have two answers here. If this turns out to be 0, right? If that's 0, then that's not there. Then we're only going to have one answer. But if this turns out to be something other than 0, we're going to potentially have 2. So I need to do this first. I need to do this. So there's a couple of ways that you can do this. What I like to do is I like to isolate everything after the negative right here, and just multiply those three numbers together. So 4 times 3 is 12 times negative 12. What's in the blue box is 12 times negative 12 is negative 144. But you're going to subtract a negative, so that's going to become plus. So this becomes 256, and because again the double negative, you get plus 144, and then all of that over 2 times 3, which is 6. So now we have negative 16 plus or minus square root. Let's see, this is that 400? Yeah, 400. So this is 400, and then over 6. And what is the square root of 400? Well, it turns out that this is a nice problem that they've given us to try here. This is going to be negative 16 plus or minus. Now, you could do square root of 400 on your calculator. You should know how to do square roots on your calculator, but that's just 20 times 20, right? 20 squared is 400. So this is plus or minus 20 all over 6. All right, we still have work to do. Now what I'd like to do is look at the two different scenarios we have, the positive and the negative. So if we take the positive, we'll look at this little road, and if we do the negative, we'll look at this little road. Okay, so what happens if we do the positive? Negative 16 plus 20 over 6. Well, do the negative 16 plus 20 first. That's 4. 4/6. And that reduces, let me make sure I'm still on camera here. It's getting close. This is 2/3. Okay, reduce the fraction. Then over here, if we do subtraction, negative 16 minus 20 over 6. The top is negative 36 over 6, which is negative 6. So we have two answers, two solutions for this. X is 2/3 or X is negative 6. So I don't know if I'm going to tell y'all or not in class, but I'm on a little health kick right now. I'm getting back in shape, and I'm doing my solutions in here, and they have this tray of snacks and candy. It's temptation here. I'm not going to touch them. But it figures there's never food in this room, and then the day I come in here after I've started working out, there it is. Okay, we're moving on. Number 9. Number 9. All right. Oh yes, the difference quotient. I know that in my 1324 class last semester, I promised them that the difference quotient would come into play. So they give you a function, and it is a quadratic function, 2x squared minus 5x plus 3. And they say find f of x plus h minus f of x all over h. And this was called the difference quotient. So the way that this works is that we actually have, I like to look at it as 3 pieces, top left corner, top right corner, and then the bottom. Now the good news is that the bottom is just always going to be h, so we don't have to worry about that. Other good news is that the top right corner, all you're going to do is take the function you're given, whatever this is, and you're just going to stick it right here. The complicated part is this piece right here. F of x plus h means we have to take our original function and replace all our x's with x plus h's. It does not mean that all we're going to, this right here does not mean all we're going to do is add an h to the outside of this. No, it's replacing all of these x's with h's. So what I like to do is before I actually try and find the difference quotient, I just try and figure out what that f of x plus h is by itself. So I'm going to rewrite that expression 2, but instead of x squared, I'm going to put this squared, x plus h squared, and then minus 5 times, now instead of x, x plus h must have it in parentheses. Notice that both of these were in parentheses. That's because the squaring is going to impact this entire expression, and then this 5 is going to multiply times the whole thing, so that, or negative 5 is going to have to distribute through. And then we have the plus 3, nothing changes there. We don't need to do a plus h or anything like that. The x plus h's have been accounted for right here. All right, so now let's continue. I have a 2, but then I have to square this. And when you square that, you have to be real careful, because it doesn't mean you just square each one. No, 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 that would be a mistake. What it means is that you have to take that and multiply it times itself, which means you have to FOIL it. And when you FOIL it out, you get x squared plus xh plus xh plus h squared. So that's what happens when you FOIL. You get those two middle terms in here, and those two actually come together because they're the same thing. You get 2 of them. So I have the 2 out here, and then this piece right here, is going to be that, but I'm going to go ahead and drop those 2 together like that. So this becomes 2, and then I'm going to put in parentheses. It'll become x squared plus 2xh plus h squared. So this piece right here, right, is that. And then here, all we have to do is distribute the negative 5 through. So I get minus 5x minus 5h, and then plus 3. Okay, one more step. Let's pass the 2 through. So we should get 2x squared plus 4xh, so there, and then finally here, plus 2h squared. So this had a 1 in front of it, becomes a 2. This had a 2 in front of it, becomes a 4. This had a 1 in front of it, becomes a 2. And then these right here, minus 5x minus 5h. It is critically important that you remember a couple of things here. When you square a binomial, you have to do that, and that if there's a number out front, that must pass through everything. Okay, those are common mistakes I see. All right, at this point, see if there's any like terms. Is there anything that has exactly the same variables, exactly raised to the same power? And I do not have anything that's like terms. Nothing matches up. So that's it. This little guy right here that looks so innocent turns out to be this big, ugly, nasty thing. And that is just the top left corner of this expression. So I'm ready to write this down. This is equal to f of x plus h, which is this, 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 3. So to reiterate, this right here is just that. Okay. Now what I need, and I'm going to erase this because I'm done with this. This was kind of scratch work I was doing on the side. Now I need to do minus, so minus f of x. Now f of x is this piece right here. It's the whole thing, right? So I need to subtract that. So what I'm going to do is I'm going to put in parentheses 2x squared minus 5x plus 3. Again, that's another critical point that I see students make mistakes on. One of the most common mistakes with difference quotient is to forget the parentheses around your f of x, because the negative sign must distribute through, right? If you don't have these parentheses, then you actually think that it's just minus 2x squared minus 5x plus 3. In fact, it's not going to be that after I distribute. Now, all of this is divided by h. All right, so at this point, move this thing up here, I get equals 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 3. Okay, that's just this. Now distribute. This will become negative, this will become positive, this will become negative. So we're going to have minus 2x squared. We're going to have plus 5x. I don't know why I said 10. I saw 2 and 5, I guess. minus minus is plus, and then finally this positive 3 becomes minus 3. Then all of this over h. Okay, so if you took my 13-14 class, and hopefully your 13 and 14 instructor said this to you also, if you do difference quotient correctly, then good things should start to happen at this point. You're going to get a lot of things that cancel out. And everything that should be remaining after you cancel things out should have an h in it. So let's see. I notice I have 2x squared and minus 2x squared. So those two cancel. Let's see. I have a minus 5x and a plus 5x. Those cancel. I've got a positive 3 and a negative 3. Those cancel. Otherwise, nothing else cancels. So all I'm left with at this point is that that's equal to, I have a 4xh, I have a plus 2h squared, and a minus 5h. I have those three terms right here. 1, 2, 3. Those are the three things I still have on the top. And on the bottom, I have h. And like I said, if you do things right, you should have h's in everything you have up here, which we do. And that's a good thing, because now what you can do is you can factor out a single h out of the top. So if I pull an h out of here, h out of here, and h out of here, I'll be left with the 4x. I'll be left with plus 2h, because I pulled one h out, I still have one h, one factor of h here. And I pull that h out, I get minus 5. And that's all divided by h. And h over h, it's going to just cancel out. And you're left with just the 4x, no more fraction here, plus 2h minus 5. And we are done. Okay. That was a lot of work. So that is the difference quotient, and we will be looking at what that difference quotient means, how it's going to come into play, how we're going to use it to help us answer some pretty interesting questions. All right, number 10, last one. All right, so we're supposed to add these two rational expressions together. Okay, when we add two fractions together, they must have the same denominator. In this case, they do not have the same denominator. This one has the factor x minus 4. This one has the factor x plus 4. So what we need to do is we need to introduce something to both fractions, a hidden 1. So there's a hidden 1 next to both of these. And we're going to rewrite that 1 in a very clever way so that we get the same denominators. So keep in mind, this is two terms down here. That's two terms. So since I have an x minus 4 here, I need an x plus 4. I need to actually introduce x plus 4 on the top and bottom. Notice I did that in parentheses. And since this has two terms, I'm going to put that in parentheses. So this is really a 1. And so that doesn't change the problem. If I multiply this by 1, it shouldn't change. But by doing this and multiplying through, it's going to look different. Even though it's not different in terms of its value, it's going to look different. But it's going to have the same denominator. That's the key. Okay, here we need something, top and bottom. So we have an x plus 4. I need the x minus 4. So I need x minus 4 here, x minus 4 here. Again, we had two terms here, so I'm going to go ahead and put those in parentheses. Now what we'll do, since they have the same denominators, is we'll put these two together. So we're going to have one big numerator. On the bottom, we just have the common denominator. Just a single common denominator. We don't write it twice or square anything. It's kind of like when you have 2/3 plus 5/3. This is 7/3, right? You just take 2 plus 5, you add them, you get 7. You just keep the common denominator. That's what we're doing here. We're taking like 2/3 plus 5/3. We're going to have 3 on the bottom no matter what. So the common denominator is on the bottom. But now what we have to do is we have to take this entire numerator and add it to this entire numerator. So I'm going to take the x plus 4 times 2x minus 5. I'm going to add that to x minus 2 times x minus 4. Now, I'm not done. This is just putting it all together into one fraction. I need to multiply this out, right? You have to do multiplication before you do addition. So I have to multiply these two together, multiply those two together, which means, yes, you have to expand this or FOIL it. You have to expand this or FOIL that, however you want to say it. And then we can start putting things together. So this will be, let's see, x times 2x is 2x squared. And then we have minus 5x plus 8x. That's going to give us 3x. Kind of going a little faster there. And then minus 20 is what we get when we do 4 times negative 5. Then I have plus. Now for this, I don't need to put this answer in parentheses by itself because this is a plus. I don't have to worry about distributing a negative through, which would change the signs. A plus leaves everything alone. So it's safe for us to just go ahead and multiply x times x, get x squared. And then here we go, minus 4x minus 2x is minus 6x. And then finally, negative 2 times negative 4 gives us 8. Now all of this is over the common denominator, which is x plus 4 times x minus 4. And now collect like terms. So in terms of x squareds, I've got 2 of them and then 1 of them, so that's 3 of them, 3x squared. In terms of x's, I've got 3 x's and minus 6, that's negative 3x. And then negative 20 plus 8, that's going to give me negative 12. Then all of this over x plus 4 times x minus 4. And we're done. We could multiply the bottom together, but it's not wrong to leave it like that. I'm gonna go ahead and multiply it together. I'm not going to show you the work, I'm just going to do it. Turns out that this is a difference of squares. So when you multiply, the middle terms cancel. You can do that for yourself. You FOIL it out and you get this. So we have added and simplified that expression, which again is another technique that we're going to want to be comfortable with in this class, being able to do something like that. Okay, that wraps up the first, what do we call that? The day one review.